Okay, let's continue the conversation of continuity. It says determine the values for constants a and b such that f of x is continuous everywhere. Recap that a function is continuous when f of a exists, when the limit as x approaches a of f of x exists, and the limit as x approaches a of f of x is equal to f of a. So we take note that our piecewise function is connected at two x values. So we have three parts in our piecewise function. There's a connection at x equals -1 and at x equals 3. So we'll let a be -1, and we'll also let a be 3. We'll first start with a being -1. So f of -1 must exist. And does it? Well, if we pay attention to our piecewise function, and we take note where x is equal to -1, we see that the function value is 2. So f of a does exist. What about the limit as x is approaching -1 of f of x? Does that exist? Well, in order for that to exist, the limit as x approaches -1 from the left and the limit as x approaches -1 from the right, they have to be equal to each other. Well, if we're approaching -1 from the left, we're looking at values less than -1, and that's the top piece, which is 2. So the limit as x approaches -1 from the left of 2 is just equal to 2. Then, if we consider approaching -1 from the right, we're looking at values that are greater than -1, and that is the second part of our piecewise function. And recap or remember that this is direct substitution, so we can plug the value in, -1 for x, and we'll end up with -a plus b. Now, in order for the limit to exist, these two values must be equal to each other. So -a plus b must be equal to 2. So we have our first equation. Remember, two unknowns require two equations. So we have one. All right, so now let's consider the case when a is 3. So again, f of 3 must exist. So we examine our piecewise function, and we can see that x is equal to 3 in our third piece, or the bottom part, which is -2. So f of 3 does exist. Now we need to consider the limit as x is approaching 3 of f of x. But remember, in order for this limit to exist, we have to approach 3 from the left and approach 3 from the right. And these limit values must be equal to each other. So let's look at our piecewise function. Approaching 3 from the left means we're looking at values less than 3. So that's the middle piece. Approaching 3 from the right, we're looking at values greater than 3. That's the bottom piece. So the limit as x approaches 3 from the right of -2, well, that's -2. And then the limit as x approaches 3 from the left, we can do direct substitution. Plug 3 in for x, and we'll end up with 3a plus b. So again, in order for the limit as x approaches 3 of the function to exist, these must be equal to each other. So we have the equation 3a plus b equals negative 2. So now 2 equations, 2 unknowns. Recap, this is a system of equations, so you can solve it using elimination, substitution. You can use the matrix command in your calculator, whatever you're comfortable with. I'll go ahead and use elimination, save a little time. So 3a plus b equals negative 2. And then I'll line up negative a plus b equals 2. I am going to subtract the entire bottom equation. I'll pay attention to my negative signs. So 3a minus negative a, well that's 4a. b minus b, that's gone. Negative 2 minus 2 is negative 4. So this is telling us that a is negative 1. Now to find b, I can take the negative 1 for a, plug it into either one of my equations, and solve for b. So we'll just plug it into the first one. So negative 1 plus b equals 2. So that becomes 1 plus b equals 2. So b is equal to 1. So when a is negative 1 and b is 1, this function is continuous everywhere. So remember, continuity has 3 parts. The first part says f of a must exist. The limit as x approaches a of f of x must exist. And then the last one says the limit as x approaches a of f of x must be equal to f of a. If all of this is satisfied, the function is continuous.